So one is Wing Commander Rakesh Sharma. Why? What are his achievements?
First Indian person who went for space.
So he's the first Indian person to go to space. So with the Russian had a mission where they're taken the astronauts to the space, and he is the person from India who has joined them from the Soviet Union. So what is the name of that space shuttle which they went? Yes, Soyuz T-11. Very good. Who is the other person? A famous hero? Marshal of Air Force Arjun Singh, DFC. What is DFC stands for?
Distinguished Flying Cross.
Distinguished Flying Cross, the medal he received from the British for his distinguished service. Okay. Yeah, so this is it about this thing. So I'll be heading towards the Airman-ship. So you all can see the screen. Okay, fine. You can see the slides. Seniors, talk to me because I cannot see the chat box.
Yes, sir. We can.
Yes, sir.
Yes, sir.
Okay, fine. So what is airmanship? Airmanship is a study of rules and regulations which must be followed both on ground as well as in air to ensure safety and proper discipline in the flying. Okay, and it includes all the air traffic control procedures and other actions laid down to deal with any type of aircraft emergencies and other contingencies. So why is the airmanship important for aviators? So airmanship helps to inculcate the sense of discipline among the pilots because in air, as you all know, there is nothing visible except the blue sky, or if looked under below, then if it is flying through sea, then only water or maybe a land is visible. There are no markings, nothing. So to fly safe, these disciplines has to be followed. And it's a standard procedure which is followed throughout the world, entire aviation sector. So that will help to all the flights to keep it safe and prevent from the accident. So that is why airmanship is very important. This is the basic structure of an aerodrome. You all know. So it has the runway markings, and taxiway and holding points. Then this is the hangar setup buildings. It's so all written here. So runway designation, center line. So this is the center line, number 7. Then what is 8? 8 is the aiming point. 9 is the threshold point on the runway. Then 10 is the stopway, which is extra runway, which is called extra paved runway. Then holding point. So this is the holding point. Any aircraft which comes from the taxiway, it will wait here. It will hold unless it gets the permission to enter into the runway. So then 12 is the edge marking. So these are all the edge marking. Then heads depicts the helicopter stand. So here, so this 14 depicts the helicopter stand. Then 15 is the fire station, airline service, bus stop, and then taxi stand. So this is the taxi stand. This is the 18. Okay, so what is the definition of airfield? So airfield refers to an area of land used for takeoff and landing of the aircraft and exclude buildings and installations. So basically it can be a runway. So airfield refers to a runway. So airfield refers to an area of land used for takeoff and landing. So basically a runway, we can call it as the airfield. So airport means used for civil flying, established which handles the international air traffics, and therefore the custom house of travel amenities and other things all together. We called it as airport. The aircraft classification number, it is a number expressing the relative effect of an aircraft load on a pavement for a specific subgrade strength. So basically, every aircraft has some aircraft classification number. It means every aircraft cannot land on every runway because that runway has some you know, uh, load classification number. We call it as LCN, which can handle that load which aircraft has or to land. For example, it might be a big cargo plane. That big cargo plane cannot land on some, say, small runways where the runway is designated to land only for the small aircraft. So then it may leads to, catastrophic effects. It may damage the runway as well as the aircraft. That is why air classification number is a number expressing the relative effect of an aircraft load on the pavement for the classification for the specified subgrade strength. The next, aerodrome. So aerodrome is a central point of an airfield. So basically, if you see that if you have the two runways here, which are at a 45 degrees, maybe approximately to 45 degrees, then the center of this aircraft or the airfield is marked by here with ACR, with the APR number. So that is called as the aerodrome reference point. That is defined in terms of degree, minutes, and seconds of latitude and longitude. So it is a designated geographical location of the aerodrome, normally taken as the geometrical center of the runway or the runway in case of single runway aerodrome. So this point, we call it as this blue point, which you can see here. So that is called as aerodrome reference point. So what is the aerodrome traffic zone? So if we talk about the aerodrome traffic zone, if we have, this is our airfield, then if you have two airfields here, then from that center of that reference point, that aerodrome, what we have, this point what we have taken, that is aerodrome reference point. So from that aerodrome reference point with a radius of say 1.5 nautical miles and to a height of say 2,000 feet, this entire area, we call it as the aerodrome traffic zone. So any aircraft which needs to enter this aerodrome traffic zone has to take clearance from the air traffic control of that aerodrome. So looking at the other definitions, so air defense identification zone. So air defense identification zone is defined as the dimensions within which the ready identification locations and the controls of aircraft is required. So no flight of aircraft, civil, military, or Indian or foreign designated within ADIZ defined above and B's penetration into this means air defense identification zones are these zones where the civil or any other aircraft which cannot enter it into those zones without the permission. So that is defined as here, so except the local flights that are conducted within the airspace of 5 nautical miles radius centered at ARP. ARP again stands for aerodrome reference point and vertical limit of 1,000 feet AGL. So AGL means that is above ground level of aerodrome. So aircraft when operating through or within the ADZ should obtain air defense clearance. For example, any aircraft which is entering these, so throughout the India, so you can see the air defense identification zones. So if any aircraft, civil aircrafts wants to enter into these zones, then prior permission has to be taken. Otherwise, it is not allowed to flow within the 5 nautical mile radius with an altitude of 1,000 feet. There might be possibility that civil flight might be passing through, but it should not fly at an altitude of 1,000 feet. It should be above 1,000 feet AGL, means above ground level altitude. If it is flying at an altitude of 1,000 feet, and if it is near within this, 5 nautical mile radius, then it has to take the permission of this air defense identification zones. So air routes, this is basically a map which is shown here, which is showing the kind of the air routes, which is how their routes look like. So the navigable airspace between the 2 points identified the extent necessary for the applications of the flight. For example, this is one aerodrome and this is another aerodrome. So there are many ways to go through this. One, it can be go at this path with an altitude of 6,500 with a flight level of 150. Then it goes here, then with a flight level of 100, and then likewise there are certain markings and which has to be followed. So this is another flight path, which is a flight level of FL 100. So like this, there are different navigational paths which are formed. We'll see one small video at the end of it so that we can understand how these paths are defined, air traffic paths. Now there are different boards and services. One is the Air Traffic Advisory Service, Air Traffic Control Center, and Air Traffic Clearance. So Air Traffic Advisory Service is responsible for providing service of aircraft when it is flying in the IFR flight rules or IFR flight plans. So what is IFR stands for? You all know it stands for Instrument Flight Rules. Are you all listening to me?
Yes, sir.
Okay. So whenever any aircraft is flying with IFR instrument flight rules, and it is flying to 2 different points, and it has come in contact with air traffic control center of that location, then the air traffic advisory service will come into effect, because advisory service is giving advices. It is not asking the aircraft to land or to take off. It is just giving the necessary information for a passing by aircraft which is required. Whereas air traffic control is mainly responsible for any aircraft which is coming for landing or going for takeoff. So please understand the difference between these two terminologies. Air traffic advisory service is different. Air traffic control center service means responsibilities are different. So air traffic control centers or within the control areas means any aircraft which is coming under the control areas. What is the meaning of control area? As I told you before, the control area in the sense if any aircraft coming in with this range and with an altitude of 2,000 feet, then it means it's a control area of that aerodrome. So if any aircraft within that area, so then ATC will control over, air traffic control center will take control of that aircraft and gives the necessary information. So it also provides a flight information service within the flight regions. And the third service which it will provide is an alert service. So basically, if any aircraft loses the contact with any of the ATC, then what happens? The nearby ATC will issue an alert to the search and rescue team, so that the search and rescue team can find out the last communication aircraft. Next is the air traffic control clearance. That is for aircraft to provide conditions. It's authorization for an aircraft to proceed under conditions specified by air traffic control. It means whether to take off, land, or hold position. So those are called air traffic control clearances. Now you're looking here at a diagram. If you look at this diagram, so this is one aerodrome here, and there is one more aerodrome here. So an aircraft is flying from this to this, and in between there are no aerodromes, but there are in between only there are some centers, that is air traffic control centers, which are monitoring the movement of aircraft. So these are placed throughout this, and wherever these are there, so that over air we call it as that path. You can see from the second figure here. So now the aircraft, this red zone indicates that it is within that aerodrome region. So within that aerodrome region, the air traffic control tower, aerodrome tower will be taking control of that aircraft. Once it moves out, then there is something called ARTCC, that is uh, air traffic control center. Air traffic control center will take over this aircraft, and that will be keep on guiding until unless it enter into the another aerodrome. So once it enter into the another aerodrome area, then ATC tower will take control back of that aircraft. So aerodrome traffic control services as follows. So that is preventing the collisions between the aircraft in air and maneuvering over the area between the aircraft and the abstractions, expediting and maintaining an orderly flow of traffic. That is with the help of towers, radars, and they use different tools or equipments to monitor the movement of the aircraft. So basically is to keep the two aircrafts separate with the different flight levels so that the collision should not happen. So that is the ultimate responsibility of this air traffic controllers. So then coming to the airway. So a controlled air or portion thereof established in the form of corridor equipment with the radio navigation aids. So these are the different ways of air navigation. So this is the navigational aid point. For example, the aircraft has taken from this point and it is moving ahead. So when it comes here, it has to reach to this point at the estimated time. So when it reaches to this point to the estimated time, it might be some location, it might be a physical marking or anything. So then it indicates that yes, the aircraft is going in the correct path. So that is how the air path is defined. So holding point is nothing but, for example, if this is the taxi path, aircraft comes here before hold that position. So that point we call it as the holding point. So heading. So what is basically heading is? So the aircraft longitudinal axis where it points. So that is called as, yes?
Direction, sir.
Direction of what?
In which direction it is going? Pointing.
No, it is not like that. So heading is and pointing, the heading direction and the movement direction at a times it will be different. For example, if I write here, so this is the direction where the aircraft is moving. But what happens is that, aircraft, so if this is the aircraft, we know that this axis is the longitudinal axis, and this axis through the wingtip to wingtip, this we call it as the lateral axis. Okay, so I am writing the 2D dimension graph here, a diagram here. So now the aircraft supposed to move in this direction, it is moving, but what happened, since the crosswinds are so heavy, so sometimes what happens, this crosswind make this longitudinal axis to point in a different direction, and this direction we call it as heading, and this is the movement direction actually where the aircraft is moving. So this is basically, it is measured as counterclockwise in the compass direction, not counterclockwise. It is clockwise direction, not counterclockwise. It's clockwise direction in the compass which is indicated. So this is, we call it as heading. So if there is a heavy crosswind here, so what happens then, it tends to the heading. For example, if you want to move in this say 270 degree, so the heading has changed from 272, it might be moving in 280 degrees point. It might be in the compass, it might be showing 280 degrees. Next, talking about the standards. If you look into these standards, then the pressure level, the density of air, and the temperature and speed of sound is mentioned here. So the standard pressure at mean sea level, it is represented as 1013.25. hectopascal. That is what it is mentioned. That is its unit. And density of air is 1.225 kg per meter cube. And temperature is 288 Kelvin or 15 degrees C. And the speed of sound is represented with 340.29 meters per second. And the ground gravity and the gravity is defined, you all know, there is 9.8 meters per second square. And if you look at the temperature variations, then for every 1,000 feet, then temperature will drops to 1.98 degrees. And the pressure for every 30 feet in altitude, the pressure drops by 1 millibar. Now we'll look into a few more definitions. The difference between the height and altitude. See, height and altitude are two different things. So let me show you this diagram here. This is the sea, and say aircraft is moving. Okay, so aircraft is moving in this direction. Now, the altitude at this point, the difference from this position to this position, you can call this as altitude because we are referring with respect to mean sea level. But when the same aircraft comes here, to draw, I'll just copy this. If the same aircraft comes at this point, then the distance between this land and the aircraft, this is, we can call it as height. Whereas if we again measure from this to mean sea level, then this we call it as the altitude. So this is the basic definition of the height and altitude. So height is with respect to that ground, whatever the ground elevation is there. So with respect to that, whatever the aircraft position in air, that is, we call it as height. And altitude means always it is measured with respect to the mean sea level. So in this case, the first point, the height and altitude both are same because there is no land and it is just the sea. So the mean sea level, the height and altitude are same. But when it comes over the land, then the elevation over the land, you know, the variations of the land, the heights will keep on increase, but the altitude remains to be same, which is to be at mean sea level. So elevation is one more term here. So a vertical position of a point or a level above on surface of the earth, which is measured from mean sea level. So that's what I told to you. So whenever any point is referred here, so this aircraft now is at some point, and that point of elevation we define with respect to the mean sea level. So that is another term, we call it as the elevation. Then there is something called the flight levels. Now, the flight levels means every aircraft will flies with certain height, and it has to follow these rules, that is international flight rules. For example, this aircraft comes here. So this might be flying at, say, flight level. We call it as FL. So flight level, it might be 100 here. So here it might be flying at a flight level of 500. So at any point, the flight levels, so if it is at this point, it defines how these flight levels are defined is with respect to the pressure. So what is the air pressure at this area at altitude? So that is, we call it as the the flight level. And again, what is the pressure, the air pressure at this point or this elevation with respect to the mean sea level? Again, that is designated by one more standard of the different number of the flight level. So that might be called with another flight level number. So this is how it is defined, the flight levels. So flight levels is basically defined with respect to the pressure at that elevation level. So you can see this from the diagram, the flight level. So when the aircraft is flying at this level, it might be at flight level 50, but then again it is increased its height. So now if you see, this MSL is a mean sea level, which you can see from this diagram. So throughout this image, this mean sea level remains to be constant. But whereas the roughness of the ground, it's keep on varying. It is not constant. At this point, it is increasing, then decreasing, and so on. So this is, we call it as elevation. As I told you before, this is the elevation point. So then from this elevation point, from this point to this point, we call it as the height, as I told you before. And from mean sea level to the aircraft, that we call it as the altitude. So now altitude is always measured with respect to mean sea level, and the pressure variations are always exist in this flight level. So that will define which altitude the aircraft is flying. So that will keep the two aircrafts safe, because another aircraft flying at, say, flight level of 70. So it means however he moves, that pressure remains to be, if you see here, what happens, the pressure when it comes to this point, it remains to be constant. It is not flying like this, it is flying above. So now what happens, the constant pressure is maintained through this path. So it is constantly moving through like this path. So that will keep the two aircrafts free from the collision. Next, transition altitudes. So altitude in the vicinity of the aerodrome at or below which the vertical point of the aircraft is controlled by the reference to altitude above mean sea level or height above the aerodrome, depending on the whether QNH or QFH is set on the altimeter. So QNH and QHF are the again two terminologies which are used in the aircraft instruments which are set in the altimeter. So if it is set to QNH, then it will be measuring the altitude with respect to mean sea level. Then if it is altimeter is set to QFE, then it will show the elevation with respect to ground. So that is what it means. Then transition layers, the airspace between the transition altitude and the transition level, means the airspace between the transition altitude and the transition level. The depth of the layer will normally be insignificant and will in case never exceed 500 feet. Means the transition layer is nothing but, for example, if I write here, so let me go down here and write. So if this is the ground here, so let us consider this is a ground, then okay, just to make you understand, think this is a vertical separated, this is the altitude or height, because I have not considered the mean sea level here. So this is just a ground. So from this ground, this might be a flight level 50, this might be a flight level 60. So the difference between these two layers of the transitions is with a gap of 500 feet minimum. So this is the minimum distance between the two flight levels. So that is what it means. Next, transition level, the lowest flight level above the transition altitude. It will vary in accordance with the relationship between Q and E and the standard pressure aerodrome. So here is what we are looking into. So as I've shown you in the previous diagram, so this is the transition layer within which, now for example, this is aircraft is taking off with the QNH settings. So QNH means it will show an altitude with respect to mean sea level. Then it enters into first flight level, then it will go to next flight level. It depends on the flight plan, how it is planned. Then it might be supposed to fly at say 10,000 feet. So then it will cross first flight level, then go to second flight level, and then it might be flying at the second flight level. Then at the landing approach, then what happens? It has to reduce its altitude. Then it will come back from that flight level to next flight level. So these are the transition levels TL, and this is a transition altitude. And the separation between these two, we call it as the transition layer. As I told you before, the two terminologies, that is QFE and QNH. So basically, this is readings given from the aerodrome. So QFE basically, it will be different at the different airfields. It is not same. For example, if we look into the Mangalore airfield, then QFE is different because it is situated at the different height from the sea level. And if you look at the Bangalore airport, then again its altitude with respect to mean sea level is different. So then that pressure level is measured at the local aerodrome. For example, what is the pressure at that aerodrome is measured locally, and that pressure value is given and that is set. So once it is set, then what happens? You are set to QFE. So once you set to QFE, when you are on the land of that particular aerodrome, then it will show an altitude of 0. So this will help an aircraft during landing and takeoff. So once the aircraft has takeoff, then they will switch to QNH to understand the altitude with respect to mean sea level, because they don't want with respect to that aerodrome. Now they are not in that aerodrome, so it doesn't make any difference. So QNH always sets its value here. If you look into this, they are setting this value, the pressure value, that is 1013. That is the air pressure. With respect to mean sea level, that is set, and accordingly as you go above and above, so what happens, that pressure drops, and accordingly the altimeter starts working, and it will give you the what is the altitude. The standard altimeter settings, so that is what, as I told. So when set to the pressure of 1013 millibar, then altimeter is indicating altitude with respect to mean sea level. Now coming to the other definitions. What is the difference between the prohibited area and the danger zone? Anyone answer this?
Sir, prohibited area that we cannot enter, it may or may not be dangerous, but danger area is
Danger is danger. Prohibited is prohibited.
Sir, prohibited, it may not be or may be dangerous, sir.
Roshni, you have some question. Does it depends on magnetic field? This is related to what? I didn't understood your question. I have not seen your question. Roshni, you are there? Yeah, so this question is related to which topic? You're not audible, Roshni. You can type it otherwise. Okay, see, on heading. Yes, it is related to, when we are talking about heading, it is related to the magnetic field, because we are taking the true north into consideration, because all the compass works on the true magnetic north. So it is a magnetic field. Yes. Coming to this thing, prohibited area and dangerous area, it is prohibited area is when you are flying, when you are in air. Dangerous area when you are on land. You keep this in mind. So this is the basic difference between the two. So don't get confused. Prohibited and dangerous area. So prohibited area means, for example, you are flying and you are not allowed to fly over that land or water, above that land or water. So that is called as prohibited area. Whereas dangerous area means you are already in the ground, the aircraft is already on the ground, and the aircraft cannot, are not supposed to enter into that area because that might be under construction or might be some problem might be there. That is why that area we call it as dangerous area. Hope Kiran, it is clear to you. Okay. So again, restricted area is where the aircraft, again, when it is in the air, it cannot enter into any land or the water bodies above which it is restricted. So it might be a defense area where the civil aircraft is restricted to fly nearby or to pass by. So that is called as restricted areas. So this is some flight paths. So visibility is another terminology. So visibility is the atmospheric conditions, which is very much required. It is measured in the distance. So basically the visibility which is required, it is at least 5 nautical miles, 5 kilometers to 8 kilometers. Visibility should be there for any aircraft to take off. And load class, yes, who is that? So load classification number means it is the number which is given for runway. Please do not get confused. The number which is written on the runway, that is different. That is the runway number is different and load classification number is different. Load classification number defines how much load that runway can take or what kind of aircraft it can allow to land. So that defines the load classification number. Means it depends on the type of construction, how that runway is designed, how much load it can withstand and all those things. Then alert service is, as I told, so alert service is for search and rescue. Then alternate aerodrome. Alternate aerodrome means every flight plan which is prepared by an aircraft. So they have to give the flight plan and alternate aerodrome. For example, if the aircraft is supposed to go from here to International Airport Bangalore, then they have to give an alternate aerodrome for any case if that runway got busy or some aircraft got stuck in the runway and they could not clear the runway and could not give permission to land, then it should head back to an alternative aerodrome. So that is, we call it as alternate aerodrome. So distress message. So distress message means, for example, if any aircraft under threat or anything, so they will generate a distress message over the wireless, and again it is given to the alert service. Then ceiling is the height, the maximum height above the ground or water of the base, the lowest level of the cloud, say it might be 20,000 feet. So that is, we call it as ceiling. So estimated time of arrival. So this is basically you are looking into the the air traffic route plan. So if you're looking at the air traffic rule plan, there are few buildings here. If you can observe, there are few buildings and installations and towers. So if any aircraft which is passing through these, and these aircrafts and towers are given with certain numbers. If you can see here, there is 627, 705, 558. So all these are given, and there is a well which is of given number as 601. If any aircraft is passing through this, then the time of takeoff and the time to reach these points has to be calculated pretty earlier, and the speed or the cruising speed at which they are moving. So everything is go fine, then they should reach at that particular time at this location. So then that indicates that they are in the right path or their airway is correct. So that is how the aircrafts make movement in the air or in the space. So this is possible only in the VFR conditions. VFR means visual flight rules, means when the visibility is very clear, when you can see the objects very clearly, there are no any atmospheric hazardous conditions, and you are flying in a visual flight rule condition. If the weather condition is bad, if it is foggy, rain, then you cannot see any of this. Then the aircraft has to switch to instrument flight rules, IFR, with the permission from air traffic controller. This is a simple flight plan. This is how it looks like. Any aircraft which before takeoff of 24 hours, they have to fill this kind of flight plan and they have to apply it. And they have to submit to air traffic controller and subsequently to all other air traffic controllers throughout the path. So what does it have? It has the address, timing, origination from where, then aircraft identification number. As I told you before, aircraft identification number, every aircraft has certain identification number. Then departure time, then what is the endeavor time, what is the total time that it may take to travel. Then where survival equipments. See, survival equipment, survivability of air survivability is one more topic which we'll discuss in the coming classes. Where, for example, the aircraft has to be prepared for their survivability through which path they are moving. Or, for example, if they are moving through, say, over the water bodies, then they should have dinghy. They should have the survivability kits, which is required for survive on the water. If they are flying through deserts or lands, then the equipments are different. So all those details has to be mentioned in this kind of flight plan and has to be submitted. Okay, I think we are done with slides. I wanted to show this for your juniors, but I missed this slide today. So anyway, I'll do this for them in the next class. So I'll show you one small video, then we'll wind up this.
Today, about 600.
Can you all see the video?
No, sir.
Okay. Can you see now?
Yes, sir.
What about other cadets? Can you see?
Yes, sir.
Okay.
About 650
Is it audible?
flights take off from one of its two runways. At the
Yes,
busiest,
sir.
this represents one aircraft every 45 seconds. Of those 650, about 20 flights daily head to Frankfurt. Between British Airways and Lufthansa, flights on this route depart more than hourly throughout the daytime. This makes Frankfurt one of Heathrow's most frequently served destinations. Despite the unremarkable nature of such a flight, the complexity of even this 1 hour hop is enormous. It takes dozens of people spread out all across the continent to coordinate and navigate just one of these flights safely to its
This video is all about
This is everything
aerodrome
that
control,
happens with
how
the
it functions and
minutes
all.
it takes for a plane to get from its gate at Heathrow to its gate in Frankfurt. Hours before the flight is scheduled to take off, British Airways will have sent a flight plan to here, Eurocontrol's Network Manager Operations Center in Brussels. Now, Eurocontrol is an intergovernmental air traffic management organization.
Well, Eurocontrol is an intergovernmental organization of 43 states, Eurocontrol and beyond, and we do air traffic management service transversal.
What that means is that Eurocontrol deals with a variety of different aspects of the job of managing air traffic in Europe. One element of that is what's called network management. This function essentially involves, from this room, making sure that flights make their way through Europe as safely and smoothly as possible. That field is headed up by Sopo Prisignati, Eurocontrol's Director of Network Management.
So here you see that's our operational room. The scope is to provide services to 43 air navigation service providers, to provide services to more than 500 airports, and to provide services to more than 1,000 airlines over the network.
One corner of this room is devoted to checking those flight plans that airlines send in. Now, what they need to check is that these plans are following the rules.
So this is very important.
Two aircraft, the sky does not look like this, but rather this. At least
See, the land has been now converted to this kind of map where it shows all the flight paths.
in most of Europe, there are thousands upon thousands of predefined airways, each with their own rules on directionality and routes and more. So aircraft not only need to fly on these roads, but they also need to follow the rules of the roads. Looking at this map, you can see why, for example, you won't see many planes flying over this area in the east of England. There just aren't many airways there. Eurocontrol sends the flight plans through a program to check that they follow these rules, but if the computer rejects it, Then it goes to these people in about 2% of cases who coordinate with the airline to fix it manually. From there, they'll distribute the flight plans to all the air traffic control centers that each aircraft is expected to fly over. That process happens before the flight has even taken off. Going back to that British Airways Heathrow to Frankfurt flight, once their plan is approved, the plane is fueled, loaded, and ready to go. The pilot will get approval from British Airways' flight dispatcher and Heathrow's ground control to push back. Ground control is responsible for navigating all the vehicles and planes safely across the apron until when they reach the runway. The moment an aircraft gets to the runway, they are then the responsibility of tower control, which, assuming all is well, clears them for takeoff. As the plane reaches altitude, it will be passed off to the London Terminal Control Center, located here near Southampton, which navigates aircraft through the complex London area airspace until they reach 24.
So this is the air traffic control center. As I told, this is the red one which is showing here, that is the aerodrome. So once the aircraft has been taken off, so then the control is taken over by this air traffic control center, which will be monitoring the flight of this aircraft.
4,500 feet, or flight level 245, which for this flight should be just about when it reaches the coast. From there, they'll be transferred to the London Area Control Center, which is physically located in the same building, to navigate them across the channel. Once they reach about halfway across, however, they leave the UK's airspace and enter Belgium's. With that, they are now the responsibility of the Maastricht Upper Area Control Center, also managed by Eurocontrol.
We are a European non-profit cross-border military civil air navigation on the season and the day per day.
It's one of the busiest and most complex airspaces in Europe, especially as it receives a significant amount of traffic climbing from or descending into 4 of Europe's 5 busiest airports: Heathrow, Schiphol, Frankfurt, and Paris-Charles de Gaulle. Every single one of those flights, as long as it's between flight level 245 and 660, is in contact with the people in this room. Now, the Maastricht Control Center's airspace is divided into 3 sector groups: the Brussels, Hanover, and Deco sector groups. Each sector group is staffed by their own set of controllers who only work on their group. A Brussels sector group controller would very rarely switch over to the Hanover group, for example. Many controllers spend their entire careers working at one control center within one sector group. This allows them to really learn the design of their airspace in depth. Each of these sector groups is then divided into sectors themselves. Now, sectors can be divided both horizontally and vertically. For example, there's the Luxembourg sector between flight level 245 and 355, and also the Luxembourg High sector above flight level 355. At the very busiest times, each sector will have its own dedicated set of controllers. At less busy times, though, they can and do combine the upper and lower sectors together, so they're staffed by one set of controllers. At the least busy times, such as in the middle of night, they'll often combine a number of sectors. For example, the entirety of Belgian airspace is typically controlled by one set of controllers in the dead of night. In charge of each sector are 2 controllers working as a team. One is in charge of talking to pilots, the other is in charge of talking to their counterparts at other sectors to coordinate handovers. Now, in practice, for that London to Frankfurt flight, before it enters Maastricht's airspace in the Cooksey sector, they'll receive info on where and at which flight level it will arrive. They'll also get info from the flight plan on where it's supposed to exit their sector. An aircraft might also enter at one altitude and be planned to exit at another. The task is then to safely navigate the aircraft from the entry point to exit point and deliver it to the next sector at the desired altitude. Now, assuming no added obstructions such as weather or airspace closures, the main obstacle is to avoid. There are rules about how close it can be to another in order to avoid any chance of mid-air collision, and the controller's job is to make sure that these rules are not broken, or, if they are, to get to the correct level of separation as soon as possible. An aircraft must be either vertically or horizontally separated from all others at any given time. What this means is that typically, a commercial aircraft cruising at this altitude can be as little as 1,000 vertical feet separated. They have to be at least 5 nautical miles, 6 miles, or 9 kilometers apart if they're within 1,000 feet vertically. Now, in order to achieve the goals of getting the aircraft to its exit point without breaking minimum separation, there are 3 factors that the controller can instruct the pilot to change: speed, altitude, and direction. That is essentially what a controller spends most of their time doing, determining where the aircraft needs to go, how to get it there, and communicating that to the pilot. Soon enough, after just a few minutes, as the aircraft reaches its exit point from the sector, it will be passed on to the controller of the next sector. In this case, it will go into Nikki sector, then Olno sector, then it will move on airspace beyond what the Maastricht Upper Area Control Center manages. As the plane starts to descend, it will be passed on to controllers dealing with lower airspace, then approach and tower control to guide it into landing. All told, on just this hour-long flight, more than a dozen air traffic controllers will have dealt with this aircraft. But that's what happens when absolutely everything is going right, which is rarely the case. You see, back at Eurocontrol's network manager room, the second thing they do with the flight plans they receive is to make sure that once an aircraft gets flying, there are actually enough air traffic controllers to manage it.
So air traffic control, they decide on their capacity, i.e. how many flights can safely be handled in one piece of airspace by one air traffic controller. That's their decision based on their staffing, based on their infrastructure, their tools, and that is communicated to us.
So there's a limited number of flights a single air traffic controller can handle, but there's also a limited number of air traffic controllers. It's no secret that Europe, along with much of the world, is suffering through an air traffic controller shortage right now. Simultaneously, along with much of the world, Europe has been experiencing a tremendous increase in its number of flights. This supply and demand mismatch has consequences. In 2018, 60% of all en-route delays, as in all the aircraft, they'll reduce overall delays by delaying flights. Sometimes it's just for a few minutes, sometimes it's for longer, but if you're flying in Europe and you hear that your flight is delayed for air traffic control reasons, made in this room. It's just like a ramp meter on a highway. They let a manageable number of flights fly at any given time when there are capacity constraints. Now, when a flight receives a delay by Eurocontrol, the airline essentially has two choices: accept the delay and wait it out, or fly a different route. Airlines have access to Eurocontrol's system to help them make this decision.
For instance, here's a flight, it's a Thomas Cook flight from Manchester going to Antalya in Turkey, and they have planned this blue route here.
This is the route that Thomas Cook has decided is best for them. It's the least expensive considering fuel costs, overflight costs, and everything. Given that it flies through capacity-constrained areas, though, to fly this route, they would have to sit through a delay.
Through our system now, they can look at to see, okay, where are routes that do not give them delay? Those are all the blue routes you can see here. And actually then there is a gray route here, which is the shortest of the blue. So system says if you want to avoid your route which has delay, you can take blue routes or the shortest route, which is the gray, and it's up to you.
The airline can then go and decide whether it's worth it to them to fly the alternate route or wait out the delay. Eurocontrol's network management role is really most applicable on the worst days for flying in Europe. Their job is to make the bad days as okay as possible. An example of a really bad day for flying was Thursday, May 9th, 2019. The main issue was a large-scale French air traffic controller strike, meaning there was little air traffic control capacity in French airspace, one of the busiest areas.
If you look at this map, that shows the magnitude of the impact on the sectors that they cover.
Okay, so I think you have understood the significance of air traffic controller, how important it is in the flight controls. So, okay. So, fine. Any queries? Anyway, for you, it was just an introductory session. First thing. You're all listening to me or went to sleep?
Listening, sir.
Only one person is responding.